We decided to take our 20-year-old air conditioner from our Class A motorhome and replace it with a new AC that ran off a 12 volt that we could power from our batteries and our solar. Now I've been thinking about doing this ever since we installed our off-grid solar and battery system, but there was one big problem. I really didn't know where to start, and I wasn't sure whether this was going to be one of those traditional mini split units or something else. I want to take you through what we ended up getting and how it eventually all came together. And does it actually work? Now what initially started this whole thing was the fact that our old air conditioner heat pump unit actually died. It was a dual compressor unit, and one of the compressors had already been kind of not working very well. So eventually, something happened, and I think we probably hit a giant pothole somewhere. Instead of trying to fix it and replace it and all that stuff, it was a good time to actually start to look for something better. So of course at first I looked at all of those mini split AC units that are primarily used for residential use. They have the head unit that you put inside, and it's got the evaporator coil and compressor unit that's on the outside somewhere, and they run off of 120 volt AC usually, and they have all these long kind of, I think, still copper lines. I decided not to go that route. For a number of reasons. First of all, I needed something that was very ruggedized, kind of designed for the punishment that I was going to put it through. We're always on really rough roads, and whatever's in the back end here is going to take a lot of punishment and exposure to dirt and the elements, and I needed something that was going to withstand that abuse and that shock. Also, I didn't want any additional equipment that I had to install on the inside of the RV. I didn't want head units on the wall, blowing in there. I wanted to use the existing ductwork. Since we primarily are out camping off-grid and boondocking all the time, we needed something that we could run more frequently, and a 12 volt option was something that I was really looking into, and I've been doing a lot of research on it. But I had some unique criteria specific to our RV. Now the old system was a basement system, so it actually lived in the basement below our bedroom area of the RV, and I wanted the new system to actually sit in that same spot and look like it was an OEM piece of equipment. I didn't want to have to not use the ducting anymore, so my goal was to try to find something that I could use the existing ductwork. And of course I wanted it to be more efficient than the other one, so I wanted to be able to use less power so that we could power it off of our solar and our battery system. Now we have ample supply of solar, and we can regularly pull in between 1,000 and 14, 15, sometimes more, 100 watts of solar. I wanted an air conditioner that I could power for under 1,000 watts and cool down the rig. So that was my goal, 1,000 watts, and to be able to use the existing ducting system throughout the RV. Now, what I ended up finding after a lot of research was this company called Cruise and Comfort. Now they build really ruggedized systems, and they've done a lot of installations on vans, a lot of smaller spaces like vans, and big old racing speedboats, and some military and industrial applications as well. So they're kind of built to the specs that I think I wanted, but they didn't really have some direct kits or equipment that were designed for this large space. I ended up contacting them, Chris, the owner. We spent a lot of time on the phone trying to brainstorm and figure out, is it possible to kind of piece some components from different kits they had to put something together that might work for me. What we started with was this 18,000 BTU dual compressor setup that ran on 12 volts, and that was kind of the main compressor unit for this system. And from there, we added two smaller evaporators that had a blower in it and an evaporator coil, and I could use two of them together and attach those to this this compressor unit from one of their other kits. And from there, there was a very large condenser coil, and that would be large enough, actually a little oversized for what I needed. And there's some other smaller stuff like this receiver dryer component. And of course there was all the wire harnesses that connected everything together. They were able to include this Wi-Fi programmable thermostat, which is kind of a bonus I was hoping for, so I could access this whole system remotely and control it and monitor it and all that stuff. Things that would need to be added later would be the refrigerant hoses that connected everything, and I would have to figure out all the ducting and all of those things that would actually make this whole system tie into our RV. And would it provide enough airflow to be able to push all that cool air through the ceiling of the motorhome and be able to cool down the RV? I just didn't know yet. I had to figure out how I was going to organize and arrange all of this equipment in the space that I had available, and how was I going to support it. So this is the original frame, the support frame from the original heat pump unit that I took out, and we're going to reuse this for the new system, but it's going to be shaped a little bit differently. So this is from the original air conditioner. I've obviously cleaned it up a little bit, and I'm still going to use this to support the new system, but it doesn't need to be as wide. What I'm going to do to the front here of the support system here is actually cut it, and I want this front support beam to be about 3 inches higher. So it's going to be a little L-shaped thing here. The reason for that is that the large condenser unit, it's now going to be angled slightly underneath this whole thing. So by lifting this a little bit, it's going to create a little bit more space for me to angle it down and below. We'll use this bottom. We'll make this shorter, narrower, probably end about here, and everything will go into the ducting this direction. Yeah, I think it's going to work. Well, this looks like it's going to work out pretty well. It's going to get the equipment up a little bit higher, so I'll be able to raise this up about, say 10 inches from where it was before. And, I've got these threaded rod bolt setups here that are going to allow me to adjust it up and down if I need a little bit more clearance. With it sunk down a little bit in the middle, I'll still be able to get that compressor unit in here, and it'll be nice and snug and almost on level with the what's going to be back here, which is the other pieces, the evaporators. There's going to be 2 evaporators, and then I still want to trim these L pieces down so there's a slight angle, so that large condenser coil is going to sit below this at a slight angle. Let me show you what I'm using to support this. This is going to be the front, so facing the outside. Now I have this 1/2 inch threaded rod and I welded a nut onto the bottom. So that's going to actually go through the frame on the RV that already has a nut welded to the frame, so it's going to thread right in there. The frame's going to be here, and the nut's going to be on the bottom, so that'll be used to tension this whole thing up. And this is going to support this frame here that's going to sit on top of it. Now, something I took out of the old compressors that were mounted to the feet of the compressor were these nice little rubber shock mount feet. So I took them off of the old compressors and I cleaned them up, and I'm going to reuse them. What I've got going on here is a washer. So I'm going to place a washer here on top of this guy, and then take one of those shock mounted feet. I'll slide it down here so it sits on top of the washer like this. And then I think you can see where this is going. And this slides in through this hole and provides a little cushioning here. I get another washer. Here it comes. Sits on top. Okay, so there we have it. Now, as a guide on the top, this is going to be mounted to the outer wall, the mounting surface where the whole frame is mounted to, and I have a little guide here on the top. Keeps the whole system in place, and one of these is going to be on each corner as well. The way that I needed to mount the condenser unit was actually going to be below that main shelf. It needed to be mounted on a slight angle, so I needed to also build some support arms that were going to hold it in place and attach it to that main support structure. So once I had the condenser laid out here and I figured out where it was going to be in reference to this whole frame, I had to add a couple more support brackets. So I welded on a couple more. There's a kind of an L-shaped thing here and another piece of angle iron here so that I could attach these mounting arms to the condenser. Now this one's a little bit longer and this one's a little bit shorter, and the reason for that is that the condenser has to be mounted at an angle. The refrigerant lines are going to go in here. The low pressure is on the top here and the high pressure is on the bottom. So this one has to be higher than this one by about at least 3 inches or so for it to work properly. I realized early on, once I started piecing everything together, that I was going to need a little bit more space, specifically for the two evaporators that had to be positioned in a way where I could combine the ducting going out. And I found some extra space basically behind the where the old air conditioner was. Now the next challenge was to figure out how to take two round 4-inch ducts and actually merge them and combine them into a duct that would be able to tie into the existing rectangular ductwork in the RV. So I ended up using some spray foam and kind of just manipulated those pieces into place and sealing them up, and I was able to actually make them fit in a standard size rectangular duct that I could then tie in to the existing ductwork that went up the back of the RV and then through the ceiling. This whole bottom piece is plastic, but there's this like 12-inch by 3 1/4 or so that's transition that goes up about 3 feet to the top ducting, which is also plastic. But in between, this is just foam. Crawl under here with me. Right there. See, it's just like foam. We look in there, there's a plastic piece all the way in at the top. But yeah, this is just foam. So yeah, there's the hole. We'll just tie into it right there with the L. Yeah. All right. It's pretty exciting actually seeing this whole ducting setup come together and actually work the way I thought it would. Now that everything kind of had a place, a home inside this compartment, I needed to actually fully enclose that entire space so that it was fairly airtight and, you know, protected from outside dust and dirt and all the stuff. To seal up a lot of the air gaps and joints there, you know, I use this sticky foam tape that you can use so that it created a nice airtight seal, and I use that a lot. I also insulated a lot of the interior walls of this unit, and you know, in the end, obviously a lot of foil tape and sheet metal screws to kind of squeeze everything together. All right, well, in order to power this air conditioner, it needs 12 volt power. This one runs on 12 volt. There are other models that are 24, 48 volt, but my system's a 12 volt system. It could draw up to 90 amps at 12 volts, but it's a number 2 cable that goes all the way to the back where the air conditioner is. It's about an 18-foot cable run. It's a lot of crawling underneath the RV, running cable, zip tying. Everything's enclosed in this wire loom, so it's nice and protected. Melissa said, "Oh my gosh, have you been like cleaning a chimney or something?" Because I was just covered in grime. But got it done. And also it has a nice circuit breaker here that you know, allow me to turn it off, turn it back on, and you know, provide some over current protection as well. So here's the bus bar where all the 12 volt system ties into the house. The battery compartment is over here, like I said, for our 800 amp hour lithium batteries. And you know, this is all for the starter battery. But you can see I labeled everything nicely here. Here's the positive side, and this is the negative side. I opted not to tie the negative to the chassis, just so there's a direct positive and negative going right to the air conditioner. I was able to get the LP heater thermostat controls. It's just 2 wires is all I needed. I was able to get that connected to this thermostat here, and what that allows me to do is actually get rid of the old thermostat, because I can control the LP heater now in this heater mode that's here. Even though it's just using the air conditioner, I can now control the LP heater from this thermostat as well. Now it's just 2 wires I needed. There was a 12 volt wire coming in and a switched wire. There's two ports here on the little terminal block that was for the heater, and then the switched heater. And then once I had that connected, I can program the LP heater through here and turn it on, turn it off, set the temperature, and everything works just fine. Hot air coming out of the floor. We're good to go. All right, well, after many months of design, building, and testing and trial and error, I was finally ready to get all the equipment moved out of the shop and into the RV. Got it all installed right here, in its new home and connected together. Now I can now take measurements for where all of those refrigerant hoses were going to be connected, and just kind of figure out how I was going to route those and how long each of those hoses was supposed to be. It's very specific to how you install it. It's kind of the last step, because you need the right length of hose to get between all your components. And in my case, all of the equipment was really close together, so my hose lengths were pretty short, which is actually a good thing, because it's kind of a nice compressed system, and the shorter the hoses, I believe, the better. So I put together a diagram, a design that kind of had all of the different hoses and the types of fittings and everything that I needed labeled, and I sent that off to Cruise and Comfort, and they were able to make me some custom hoses. I got the new hoses installed and tightened down, and everything was looking pretty good. And the next big step is to put some refrigerant in the system, get it charged up, and see if it was going to cool down the RV. At this time, it says December, this is around Christmas, and we're getting ready to pack up and head south and head into Mexico and Arizona. So I thought when we were down there, we would stop in to Cruise and Comfort, who's located in Tempe, Arizona, and just stop in and have Chris see this whole system for the first time and give me some tips, and also do a final check on this whole setup. I was careful not to overcharge the system, and I thought that I would wait till I got to see Chris and have him kind of tweak it and do a little bit of fine tuning for me. And I actually learned a lot from him, once we actually had a chance to play with the system and get it dialed in just right. And I also think that I got a bit of a stamp of approval from Chris.
I just don't know. It's like pushing a lot of air through a lot of area, Yeah. So I didn't think this was a good idea. I didn't think it was a good idea.
I know. You may talk to you, you're like,
yeah, but it actually works good.
We've been off grid for several months now, and we've been able to just fire up the air conditioner when we need it. And it's been totally fine, and it's cooled down the rig when we needed it to. Is it actually working as well as we had hoped? First of all, let me throw this out. We're not in 100 degree, 110 degree, desert heat. That's not how we roll. We're going to avoid those situations. But, we regularly are in, say, upper 80s and sometimes, low 90 degree temperatures. And that's when we're running our air conditioner. Even a little lower. When it gets a little stuffy inside, we can run the air conditioner. I'll typically wait till we have a good charge in the battery, and we're pulling in a sufficient amount of solar. So we'll fire up the air conditioner during those instances. And what I've found is that we have a variable range of how much power the air conditioner uses depending upon how we have it dialed in. My original goal was to be able to run this under 1,000 watts. So I'm happy to report that the air conditioner actually does run under 1,000 watts. All right, we got our AC here. We'll just put our clamp meter on that. Right now I have the air conditioner running on low, and it's drawing about 60 amps. And I've got over 1,000 watts of solar coming in, so it's totally covering the DC load here. And batteries are fully charged. All right, now we'll turn everything up to max on the AC, and we'll see how the load changes. It's blowing good now. Yeah, the system's only drawing 72 amps right now, which is pretty good. The solar is pulling in a little bit more energy to account for the rise in the DC load from the air conditioner. Now I've also got some draw on the AC because I'm also running my refrigerator on electric. Now once we got everything completely dialed in, it runs really well now, and it blows nice cold air out of the vents. One of the big issues was the actual airflow coming out of the vents. You know, I measured it before I tore the old system out just to have a baseline for what the old system was, and I put the wind speed gauge up there. It's not CFM, but it's just this wind speed measure, and I think it was 2200 is what that came in at. I measured it with the new system, and it's not quite that. On the max setting, it's about 75% of what the original one was, which is actually quite a bit. It's a lot of air flowing through there, and it's totally adequate to cool down this rig. Probably a question that is going to come up, and that is this really a DIY project? I think the answer is a little complicated, but certainly the approach that I took and some of those requirements that I placed on this project probably make it a very challenging DIY project. But if you were to take this on, say, as a project during a build, so you're building out a van or making some major renovations, and you can make space for some of these components and figure out how it's going to work within your rig ahead of time, you know, then that's going to certainly simplify a lot of these issues. I was up for the challenge, but you may not be. So depending upon how you approach the project and, you know, what components you choose to implement, it could be very difficult or it could be, you know, reasonable. You know, there's a lot of off-the-shelf kits that he has that are kind of ready to just kind of plop in. So depending upon what you choose, it's going to have a varying level of difficulty. But I look forward to seeing what you have to say about this and answer any questions that are going to come up. You know, also keep in mind that there's a lot of videos that I made for throughout the different phases of this project that go into each step in more detail. So be sure to check those out, and hope you enjoyed the video, got something out of it, and thought about an idea maybe that you could apply to your own RV. So take it easy, and I'll see you in the next one.